Hi everyone, it's time to start our discussion of trigonometry, trigonometric functions of angles. And I'm going to begin with the right triangle approach, which is basically proclaiming the definitions in light of an angle, theta, that is acute, all right, and can exist within a right triangle. When you look at the sides of a right triangle, you can see, you have a hypotenuse, you have two other sides, and there are 6 ratios that are unique. So you can say, one side to another side. One side divided by another side is a ratio. Okay, so what we do is we define these 6 functions that we are going to refer to as sine, cosine, tangent, cosecant, secant, and cotangent to represent one of the 6 ratios that we can form from the legs of this triangle. Okay, so as far as abbreviations go, we would call the sine function, we call on it by the abbreviation SIN, and cosine by COS, and tangent by TAN, cosecant by CSC, secant by SEC, and cotangent by COT. And then of course we're calling upon the sine of an angle, cosine of an angle, tan of an angle, cosecant of an angle, secant of an angle, and cotangent of an angle. And we've assigned the 6 unique ratios. So if I look at the angle theta, and I look at the side opposite theta and the hypotenuse, there are 2 possible ratios. So to one I'm going to assign the name sine, which is the opposite over the hypotenuse. To the other I'm going to assign the name cosecant, which is the hypotenuse over the opposite. And we follow through. Cosine is adjacent over hypotenuse, while secant is hypotenuse over adjacent. Tangent is opposite over adjacent, while cotangent is adjacent over opposite. Now let's look at it in light of a specific example. Okay, in the example I've provided, the figure is a right triangle, 2 acute angles, A and B, and adjacent A is the length 5, adjacent B is the length 9, and realize that when I say adjacent A, that corresponds to saying opposite the angle B in this figure. And if I say adjacent B, that corresponds to opposite the angle A in the figure. So if I want the cosecant value for the angle A, then I'll look at my definition, and I know I need the hypotenuse and the side opposite the angle A. Well, I have the side opposite the angle A. What I don't have is the hypotenuse. The Pythagorean theorem would tell us the hypotenuse is the square root of 5 squared plus 9 squared. Now, how am I getting that? I'm saying basically hypotenuse squared equals 5 squared plus 9 squared, and the hypotenuse is a length, so it's the positive square root of this value. Now we can calculate the value. And so we have the square root of 25 plus 81, or hypotenuse symbolically the square root of 106. Okay. But the point is we can use the Pythagorean theorem to get the hypotenuse, the missing side. You could use the Pythagorean theorem to get any missing side if you have 2 of the 3. And now go back to the definition. The cosecant of the angle A is the length of the hypotenuse divided by the length of the side opposite the angle A, which is 9. Okay, The next question is for the cosine of the angle B. Let's look at our cosine definition. Cosine would be the side adjacent B divided by the hypotenuse. The side adjacent B has length 9, and the hypotenuse, as we found from the Pythagorean theorem, has the value square root of 106. And these angles, of course, are all acute. A and B are acute. And so this is what I refer to as the definition of trigonometric functions of an acute angle of a right triangle. It's the most simple form of the trig definitions that we present, and then we build on this definition with subsequent lessons.